Hello friends, my name is Namami Krishna Sharma. I am assistant professor in Riva Engineering College. Today I am going to deliver a lecture on the formation of bus impedance matrix, otherwise known as Z bus matrix. So, first of all, what is the application of Z bus matrix? Why we formulate Z bus matrix in our power system network? So, the Z bus matrix is being used for the fault analysis in the power system. Its first and foremost use in the power system is for fault analysis. So, generally, let's say this is my some 3 bus or 4 bus system. These are the reference nodes and these are indicated by 0. This is bus number 1, this is bus number 2, this is bus number 3, and this is basically an impedance network, impedance diagram, and the corresponding impedances are J0.1, J0.1, J0.2, J0.1, J0.1. So I need to develop Z bus matrix for this network. So let's start how to form the bus impedance matrix of this impedance diagram. All the quantities given here are in per unit. Okay. So before going to start, let me clear 2 things here. Suppose this is my partial Z bus network. Having some buses, bus number 1, 2, bus number n, and this is my reference. This is reference, this is bus number 1 to m. Now if any new bus is introduced in this system or any new line is introduced in this system, there are 2 possibilities. It may be a branch, it may be a link. If new impedance is connected between 2 buses, for example, let's say the new impedance connect between bus number 1 and bus number 2 having some value Z12, and the another possibility may be any new bus is introduced, let's say it is n. So what will be the dimension of the matrix first of all due to these 2 modifications? So earlier for this case the dimension was m cross n. Now due to the introduction of this Z12, small Z12, this is a impedance connected between bus number 1 and bus number 2. So let me clear that no change in the dimension of the Z bus matrix due to this part. This is basically link, but if we consider this new bus n, this new node introduced here, so due to this n, the dimension of the matrix will be m plus 1 cross m plus 1. So there are 2 things. This is new branch, so it will come under the addition of branches. This is new link, it will come under the addition of link. So now we have two things, addition of branches and addition of links. Now the third possibility may be that suppose a new impedance having some value, let's say Z01 is connected between bus number 1 and the reference node. So there is a difference. There is a difference between these two, 1 and 2, and this one, 1 and 0, because 0 is the reference node. So my analysis will be different for this case, my analysis will be different for this case, my analysis will be different for this case. Addition of branches introduce a new row and new column in the existing Z bus matrix, but the addition of link re-changed all the elements of the existing Z bus matrix. It does not include any new row or column in the matrix, but it changes all the elements of the existing matrix. Okay, so this is some prior information about the Z bus matrix. Now, suppose I have to obtain the Z bus matrix for this network. So what will be the solving steps? So there are two possibilities. There are two ways to obtain the Z bus matrix for this network. Number one, convert it into admittance network, means find the reciprocal of all the admittances and then form the Y bus matrix, then inverse the Y bus matrix, then you will have the Z bus matrix. But it makes a computational burden if we are going to inverse of a matrix, 3 cross 3 matrix, 30 cross 30 matrix, n cross n matrix. So better to obtain the Z bus matrix of any given network directly from the network. So my approach is, I am going to formulate the Z bus matrix, I am going to obtain the Z bus matrix for this network by using graph theory approach. Some step by step procedure is there, very clear, very simple. So what will be my step number first for this case? Write the step number first. Yes. First of all, draw the graph of the given network. Okay, graph. This is my node 0. This is my node number 1. Node or bus. This is 2. This is 3. And connect it from 0, 1 to 0, 2 to 0, 1 to 2, 1 to 3, 2 to 3. Now name all the branches of this particular graph. Let's say it is A, it is B, it is C, it is D, it is E. Having the values of J 0.1, J 0.1, J 0.2, J 0.1 and J 0.1. This is step number first. Okay. Now the step number 2, second step. Draw the tree of the tree network. Draw the tree network of the available graph. Tree means it will consider all the nodes, but there should not be any closed loops. Okay. So first of all, this one 0, this one 1, 2, 3. So this is, now I cannot connect 1 to 2 because it will form a closed loop. So I am representing it by some dashed line. I can connect 1 to 3, yes, but I cannot connect 2 to 3. So I can represent it by some dashed lines. Okay. So from this tree network, I can identify that A, B, C, D and E. There are 1, 2, 3, 4, 5 branches in the network. Now you can see A, B, C are the border line, but D and E are nothing but the links, and A, B, C are the branches. So let me write this thing here. A, B and C are the branches and are the links. Now step number 3. Now I am going to start my algorithm, my formulation. So first of all, addition of branches. Addition of branches. We can see there are 3 branches, A, B and C. But what is the difference? A and B are those branches which are directly connected to reference node, but branch C is not connected to reference node. So I need to make it very clear that A and B are the branches which are directly connected to reference node 0, but branch number C is not connected to reference node. It is connected between bus number 1 and bus number 3. So let me draw this diagram here also. Zero, 1, 2, 3, A, B, C, D, E. A, B, C are the branches among which A and B are those branches which are directly connected to reference node, but C is not connected to reference node. It is connected between bus number 1 and bus number 3, and D are the links. So addition of branches. Now let me write one more statement here. Start with those branches which are directly connected to reference node. Start with those branches which are directly connected to node, and I can see branch A and B are the branches which are directly connected to node. Now calculation for branch number A. So there are 2 basic formulas for each cases. They are ZQI is equal to ZPI is equal to 0 and ZQQ is equal to small zpq. These are the very simple formulas for branch number A. Since branch number A is directly connected to reference node, ZQI indicates the off diagonal element of the matrix, ZQQ indicates the diagonal element of the matrix, ZQI is equal to ZPI is equal to 0, ZQQ is equal to small zpq. Small zpq means impedance associated, impedance given to me, impedance connected between bus number 1 and bus number 2, that is J0, 0.2. Okay. Now what is P and Q? What is I? So in alphabet P comes first, then Q. So for example, this one is A. A is connected between 0 and 1. So I should take P as 0, Q as 1. So for this case, P is 0 and Q is 1. I can go for I can go from 1 to number of buses, and I is not is equal to Q. When I becomes Q, switch to formula number 2, that is for diagonal element. I am repeating it again. When I becomes Q, then don't go further. Just switch for the second formula, that is for the diagonal element. Now let's start the calculation for this case. Yes. So 1, formula number 1, ZQ, Q is equal to 1. Now I can put I is from 1 to 2. Since I am putting 1, so this becomes Z11. Now there is no utility of this formula for this case, because if I start putting I is equal to 1, it becomes Z11. I cannot use this formula. I am using this one. I can use this one, ZQQ, Z11 is equal to small z, P is what? 0. Q is what? 1. Small z01. I can see directly from the network. 01 is what? J0.1. So it is J0.1. This is my first element of the matrix. Z11 is equal to J0.1. Okay. Yes. Now for the second branch, it is also connected to reference node. It is branch number B. So for branch number B, the formulas are same. ZQI is equal to ZPI is equal to 0 and ZQQ is equal to small zpq, and here P is equal to 0, Q is equal to 2 and I is from 1 to number of buses, and I is not is equal to Q. When I becomes Q, switch to formula number 2. This is formula number 2. Now start from this one. Z Q is equal to, yes, 2. Put I is equal to 1. Okay, it is off diagonal. Z to 1, I can use it. Is equal to Z. P is equal to 0. I is equal to 1 is equal to 0. So this is my second element of the matrix. Z to 1 is equal to 0. Okay. Now again put I is equal to 2 here. Q is equal to, Q is what? Q is 2. So Z to 2. I cannot use this formula. Now I am going to use this one. Z to 2 is equal to small z. P is what? 0, 2. So I can write Z to 2 is equal to small z 0, 2. 0, 2 small z means the impedance I can write directly from the network. Small z 0 to 0 to j 0.1. It is z 0.1. This is the first, second, third element of the matrix. Yes. Now the next case. Yes. So this is branch number C. C is also a branch. What we are doing? We are doing the addition of branches. Any new branch introduced in the system will increase the dimension of the matrix. Earlier it was 1, then second row and second column introduced, and this Z bus matrix is symmetrical. So Z12 is equal to Z21, Z31 is equal to Z13. Okay. Now I am calculating for branch number C. It is also a branch, but formulas will get changed in this case. For this case, the formulas for I trigonal element ZQI is equal to ZPI and ZQQ is equal to ZPP plus small zp. Okay. Now for this case, P will be, yes, P is 1, Q is 3, P is 1, Q is 3, and I is from 1 to 3. So now I am using this one. Z3, put I is equal to 1, okay, is equal to Z. P is equal to 1, I is equal to 1, and Z11 is given to me. It is J 0.1. I can write J 0.1. This is my next element of the matrix. Now put I is equal to 2. This is for I is equal to 1. Now put I is equal to 2 in formula number 1. You will get Z3 2 is equal to Z. P is 1, I is 2. Z12, and here is the value of Z12, that is Z21, Z21 and Z12 are same, and it is 0. Okay. Now put I is equal to 3 in this formula. So what I can see? Q is 3, I is 3, Z33. Is there any utility of this formula for I is equal to 3? No. Now when I becomes Q, switch to next formula, and next formula is given to me, that is ZQQ. This is for diagonal and this is for off diagonal. So I am using this one. So ZQ is what? 3 is equal to capital Z 1 plus small z 1 3, and this is capital Z11. Capital Z11 is what? J 0.1 plus small z13. Small z13 is what? J 0.1. So it becomes Z33 will be J 0.2. Okay. So now I am having all the elements of the matrix as far as branches are concerned. I have included all the branches A, B and C. Remember J and B are the branches connected to reference node. C is not that branch which is connected to reference node. It is connected other than reference buses. Okay. So let me write whatever the Z bus I am having right now. Z11, Z0.1, Z12. Z12 is 0. Z13 is Z0.1. Z21 is 0. Z22 is J0.1. Z23 is what? It is 0. Z31, yes, J0.1. Z32 0 and Z33 J0.2. This is the Z bus I am having up to now. And you can see 0, 1, 2, 3. I have considered all the buses. And the dimension of this Z bus is what? It is 3 cross 3. Now I am going to include this D. Then I will include this E. But this P is not the branch. This is link. Now the formulas will change. So this was step number 3, addition of branches. We have covered all the branches. Now step number 4, that is addition of links. Okay. Come to the step number 4. Okay, so step number 4 is addition of link. Addition of links. Okay, so the links are D and E. Now the calculation for D. So now the dimension of the matrix is not due to the effect of this link, the dimension of matrix will not change, but all the elements will be residue. I need to calculate all the elements again, Z11, Z12, Z31, Z32 and all. So what is the process? Let me write the formulas first. ZLi is equal to ZQi minus ZPi and ZLL is equal to ZPP plus ZQQ plus small zp cube minus 2 of capital Z PQ. ZLi is equal to ZQi minus ZPi. ZLL is equal to ZPP plus ZQQ plus small zpq minus twice of capital ZPQ. Now for this case D, the P is, which comes first, PQ. For P is 1 and Q is 2. Okay. I is equal to 1, 2, 3. Now use this formula. Calculate ZL. Put I is equal to 1. ZL1 is Z. Q is equal to 2. I is equal to 1 minus Z. P is equal to 1, I is equal to 1, and it becomes Z21 minus Z11. You can see the value from here. Z21 minus, Z21 and Z12 again. Z21 minus Z11, and it becomes 0 minus J0.1, and my ZL1 is minus J0.1. Okay, no problem. Now the next case, put, this is for I is equal to 1. Now put I is equal to 2 in formula number 1. Put I is equal to 2 here. So you will get ZL2 is ZQ is 2, I is 2 minus ZP is 1, I is 2. See the value from the matrix. Z22, J0.1 minus Z12, 0. So it is J0.1 minus 0. So your ZL2 will be J0.1. Okay. Now again, put I is equal to 3. Put I is equal to 3 in formula number 1. You will get ZL3 is equal to Z23 minus ZP is 1 as 3, 1, 3. Now put the values. Let me check. Z2 3 minus Z13. Okay. So Z23 you can see from here. 2 3 0 minus Z13 J 0.1. So your ZL3 will be minus J 0.1. Okay. Now you are having ZL1, ZL2 and ZL3. Now what you have to do? Write a del Z matrix here. Del Z, which is nothing but ZL1, ZL2, ZL3. Okay. So you can write del Z as ZL1 minus J 0.2, ZL2, sorry, ZL1 minus J 0.1, ZL2 J 0.1 and ZL3 minus J 0.1. Okay, no problem. Since the dimension of this matrix is 3 cross 1. Okay. Now the next is formula number 2, ZLL. What I am calculating ZLI and ZLL, I will discuss it in the next step. So this ZLL formula is given here. You know the P is 1, Q is 2, this is small, this is capital. So write Z11 plus Z22 plus small z, 12 minus twice of capital Z, 12. Now put the values. Z11 J0.1, Z22 J0.2, small z12. Okay, small z means I have to see the network. 1, 2, the impedance connected between bus number 1 and 2, the line connected between bus number 1 and 2 having the impedance of, yes, J0.2. So it is J0.2 minus 2 of capital Z12. Capital Z is what? Element of the matrix. 12 is what? 0. This is 0. So it will be 0.2, 0.2, 0.4, J 0.5. Now I have used these two formulas for the addition of link. Now what I will do with these values, that is the next step, or the, we can say step number 4A, because we have not covered link E yet. So step number 4 and the sub step is step number 4A. The next step is next formula, Z bus new is equal equal to Z bus old minus del Z transposed upon ZL. Okay, very important formula. Now the dimension of this matrix will again 3 cross 3. It will behave as Z bus old. I am calculating Z bus new, the elements of Z bus new, and Z bus new is what? Z bus old minus del Z transposed upon ZLL. So first of all, what is del Z and del Z transposed upon ZLL? I can write it as, what is ZLL? It is 1 by Z 0.5. Del Z matrix is what? Minus J 0.1, J 0.1 minus J 0.1. It's transposed minus J 0.1, J 0.1 and minus J 0.1. So first you need to calculate the product of multiplication of these two matrices. This is 3 cross 1, this is 1 cross 3, and the dimension of this del Z transposed upon ZLL will be 3 cross 3. Then you will have to subtract this one from this one according to this formula. Then you will have a new Z bus matrix. Okay, so you can calculate the Z bus new up to the effect of D. E is waiting for us. So Z bus new is equal to Z bus old minus this one. So let's say this is something Z11, Z12, Z13, Z21, Z22, Z23, Z31, Z32, Z33. Okay. Now should I stop? No, because further link is there. Link E. So the next is the addition of link and then link number E. So the same process. Which I used for the addition of D, I will repeat the same process, but now the new matrix is Z bus new. Now I will pick the data from here, not from this matrix. I will pick the data from here, and you can calculate the values by using this formula. You can calculate all these values. Now what will be the solving steps? Now see, for link number E, the Q is yes, this is 0, 1, 2, 3. So Q is 3 and P is 2. Okay. ZLI is equal to ZQI minus ZPI, and I is 1, 2, 3. Okay. Put the values. ZL1 is equal to Z31 minus Z21. This is Z31 minus Z21. You need to pick the values from here. You will get something. Then ZL2 is Z32 minus Z22. Z32 minus Z22. Pick the values from here. You will get something. Then ZL3 is equal to Z33 minus Z23. Z33 minus Z23, you will get the values from there. This is the ZL. So now write again matrix, that is del Z matrix. It is ZL1, ZL2, ZL3. Okay. Now find the ZLL. So ZLL is what? ZPP plus ZQQ plus small zpq minus twice of capital ZPQ. Okay, so yes, this ZLL is equal to ZPP means 22 plus Z33 plus small z23 minus twice of capital Z23. So just pick the values from this matrix: 22, 33, small z23, small z. Okay, small z23 is what? J0.1. Then twice of capital Z23, capital Z23 you can pick the value from here. So you will get ZLL. After that, find again ZL transposed ZLL. You will get a 3 cross 3 matrix. Now again your Z bus new will be Z bus old minus del Z transposed upon ZL. So now this matrix will become the Z bus old because you are finding Z bus new. So subtract this product from this matrix Z bus old. So in this case you can solve any problem for n number of buses by using these simple formulas. So let me write the formulas again. So first there are basically 3 to 4 formulas. Now I am summarizing my lecture. Yes. So the first one is for the branch connected to reference node. So Z QI is equal to Z PI is equal to 0. This is off diagonal. ZQQ is equal to small z PQ. Okay, this is for the branches which are directly connected to reference node. Now the branches which are not connected to reference node, ZQI is equal to ZPI and ZQQ is equal to ZPP plus small z PQ. Okay, and for the links the formulas are ZLI is equal to ZQI minus ZPI and ZLL is equal to ZPP plus ZQQ plus small zpq minus twice of capital ZPQ. After calculating all these things, you need to find Z bus new as Z bus old minus del Z transpose upon ZLL, where del Z is equal to ZL1, ZL2, ZL3. Thank you very much.